Good evening. It's a wonderful day for math, and I think that maybe you'll be like this at the start of this video, and you'll be like this after the video, nice and clear. So let's start by talking about graphs of linear functions. They're kind of an overarching thing for this section, right? We're going to use graphs to see what a function looks like so we can see its shape, where the function's zero, we're going to call those intercepts, and any other special behavior it has. And what we'll talk about in this section is mostly for linear functions, but it applies to other functions as well. That'll be useful when we do talk about graphs of other functions. So let's start by graphing with plotting points. There's two ways of doing lines. You can plot at least 2 points and connect all those points with a line. Probably have done this before or seen this before. This is where you are. You are here learning how to plot with points. And then in the next video, we'll also talk about how you can use the starting value and the rate of change to get a line. So let's do an example. I had a lot of personality when I made these notes about 3 hours ago. Let's graph this function by plotting points. So usually when we plot points, we make a table of inputs and outputs. Usually X and Y, but it doesn't have to be. A lot of times in this class specifically, we're going to use variables that aren't necessarily X and Y. This section is usually X and Y, but when we do applications, usually we'll have other things like maybe cost, which will be C, time, which will be T, and so on. So whatever things you use, go here. Technically, in this case, we'll have X and f of X. Y, f of X, same thing. So this will be our X, this will be our f of X or our Y. So let's plot some points. So choose any points you want. I like choosing an input of 0 because it's easy to do math. So then off to the side, we say, what is the function evaluated when X is equal to 0? Well, you just replace all the X's with 0. So f of 0 is equal to 5 because anything times 0 is just 0. An input of 0 is an output of 5. And again, as a reminder, this is not multiplication. This is not f times 0. This means the function evaluated at 0. So we have the point when x is 0, y is 5. We can plot the point. Let's do another one. You could plug in x equals 1, and that'll work. But sometimes there are better choices. In this case, we have, there is my circle. In this case, our slope has a 3 on the denominator. So if you don't want fractions, you could choose 3 or 6 or -3, something like that. And that's a really nice number to choose because then when we simplify, the 3 in the denominator will cancel. So again, you can plug in any points. But sometimes choosing the right points will make your life a little easier. So when we put 3 in, we get 5 minus 2/3 of 3. That's going to be 5 minus 2/3 of 3 is just 2. 5 minus 2 is 3. So we put 3 in, and we get 3 out. You can plug in the point 3, 3. We'll talk more about this later, but this should make sense because when we talk about slope, the slope here, the m value should be -2/3. Rise over run of down 2 and right 3. This is exactly what we did. We could check our answer by plugging in -3. And if you plug in -3, you're going to get +7. You only need 2 points for a line, but it's a really good idea to do 3 because then you can really make sure that all 3 are on the line. Now we'll connect these by drawing a line. Try to draw it mostly straight. Mine's not perfectly straight. Yours doesn't have to be perfectly straight either, just straight enough. It should actually go through here. So I missed it a little bit, but that's okay. That's the first example. Let me know if you have any questions. Feel free to try this next graph. Try to do what we did in the previous one. All right, pause the video, and then we'll go through it together. So let's label our axes. We could have f of x. We could label it y this time if we wanted to. That'd be fine. Either one is okay. I'm going to plug in 0 because I love 0. Put in 0 in, and you get 3 minus 4/3 of 0 out. You get 3 out. So we'll plot 0, 3. You could plug in 1. You could plug in 2. But I'm going to plug in 3 because I know that's going to cancel the fractions, and I don't have to worry about fractions. 3 minus 4/3 of 3. 4/3 of 3. The 3's cancel. And we get 3 minus 4. You should have gotten -1 if you plugged in this point. We get 3, -1. And that's all you need to plot a line. You can just connect the dots now. But if we want to be safe, let's plug in another point. Let's try 6. Put 6 in, we get 3 minus 4/3 of 6. This cancels a little bit. This cancels to 2 in the numerator and 1 in the denominator. So that becomes 8. Or -5. We get 6, -5. Going to be right here. And again, on both of these, you can see that we're going down 4, right 3, down 4, right 3. We'll get into that later. Now we just connect the dots with a straight line and make sure that you include these arrows. These arrows are really important. That means that this line goes off to infinity and beyond in both directions. Hyperreal numbers. If you're curious about what's beyond infinity, that's the answer. I'm pretty sure they're called hyperreal numbers. That's not related to this class at all. But if you want to go down a Wikipedia rabbit hole, there you go. That's it for this video. Let me know if you have any questions and have a good rest of your day. Best of luck.